How is
Sarwag each improved their yards by planting rose bushes and ivy. They bought their supplies from the same store. Okay, so I'm gonna say R equals rose bushes, I equals ivy. It's frozen. You're the best. Thank you for telling me. Okay, so Julia spent $102 on 9 rose bushes and 14 ivy. Sarwag spent $68 on 13 rose bushes and 7 ivy. Find the cost of 1 rose bush and 1 ivy. Okay, what's the easiest thing to do here? First of all, it's elimination method because they're all lined up. But what's the easiest strategy? Yes. Multiply the whole bottom by -2. Okay, so the top is 102 equals 9R plus 14I. And what is 2 times 68? Where's my human calculator? 36? Yeah. -136 equals -26R minus 14I. Actually, where's my regular calculator? Here it is. Okay. So 102 minus 36. Don't get freaked out by the size of the numbers in my calculator. 66. 9 minus 26. -17 R. This is not right. I don't know what happened. I didn't type the 1. 102 minus 136. Huh. 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 Yep. Must be Friday or just any of the days that I'm doing this. Divide by -17. 2 equals R. So you're telling me a rose bush is $2? Where? What miraculous plant store is this? Because I went to a plant store last weekend and I bought an azalea bush and it was $36. Definitely was not $2, but was not a rose bush either. But I'm assuming they would not be that much. Yeah, anyway. Okay. Which one should we plug into? Top or bottom? Top. Okay. 102 equals 9 times 2 plus 14I. 102 equals 18 plus 14I. I think that's more reasonable. $6 for an ivy plant. Rosebush, $2? Absolutely not. I don't know. I don't know what's happening here. And you just say, yeah, I don't know. And you could just say, Mrs. Talbot, just be happy that you got whole numbers. And that is what I will do. Okay, now we're going to do number 11, your favorite thing in the whole world, a flowchart. Let's go. Oh, how you love them. We haven't done one this week yet, I don't think. Oh, the excitement, the pure excitement. Okay, number 11. Mark any reflexive sides or vertical angles, then determine if the two triangles are congruent. If they are, show your reasoning with the flow chart. Okay, so I see reflexive sides right there. So I mark that, and then I look, okay, does it have 3 things on each triangle? Yes. And what kind of a thing is this? Side. And what kind of a thing is this? Angle. And what kind of a thing is this? Side. So it is Side, angle, side. Okay, I'm going to make 3 bubbles. This pen is not happy. I don't have another one of that color. This is going to be awkward. I think it's probably destined for the trash. That's just what happens with pens that a teacher owns because teachers use pens a lot. Okay, so first I'm going to do these sides with the 1 tick mark in them. AB is congruent to CD. And the tick marks were there when I got there, so that's given. And then I'm going to do the angle that was given to me, which is angle A, B, D. A to B to D is congruent to angle CDB, CDB. And that's also given because the marks were there when I walked in. And now I'm going to do the reflexive side that I marked. BD is congruent to DB by reflexive. Okay, I'm going to go alphabetical order on the top triangle, A, B, D. A lines up with C. B lines up with D. Okay. Side, angle, side. Congrats. Okay, now what I need you guys to do is find the resource page that says Penny Lab at the top. And Quincy, I'm going to need you to join a group. I cannot wait for you to count 100 pennies on your own, so. Okay. So we're going to work on the Penny Lab, but first, actually, no, we're going to do this first. Okay, I need to give you some very strict instructions on the Penny Lab. Are you guys ready? Okay, I'm going to give each group one of these little containers of pencils. Oh, Titus, join a group. Just move anywhere. I don't care wherever you want. Okay. Each one of these containers is supposed to have 100 pennies in it. Your first task is to count and make sure that you have 100 pennies in here. If you do not have 100 pennies in here, there are extra pennies in this one, or put extra pennies in that one. Does that make sense? Okay, so first I'm gonna give you one of these. Your group's job is to make sure there's 100. And then if you have too many, you're gonna put any extras in this guy. And if you don't have enough, you're going to get some from this guy to make sure that you have 100. Does that make sense? Okay, then what you're gonna do is you're going to put all of the pennies back in here, and you're gonna do your best to shake it up. You don't have to be crazy with it. And you're gonna pour them all out on the table. Understanding me so far? Okay, then you're going to separate the heads from the tails. Take a look at the table at the bottom of your resource page that says number of trials, tails, heads, experimental data. Okay, everyone in the whole room, you should start with trial 0 having 100 heads. Okay, and you guys can put you can put 1, 2, 3, 4, 5, 6 next to the trial number. Yeah, you can graph the point 0, 100. Not 100, 0, 100. Okay. What you're gonna do is I need you guys to all to listen. You're going to dump them out and separate the heads from the tails. Does that make sense? Okay, you're going to count the number of heads and you're gonna write it in the thing. So you're gonna count how many heads you got and put the number right here. Does that make sense? Okay, now, all of the tails that you got are out for the whole experiment. Those go away. Just put them in a pile off to the side. And you're gonna put all of the heads back into the container. And you're gonna shake it up and pour them out again. And separate the heads and the tails and write the number of heads, and the tails have lost and they go off into the tails pile. And then you're gonna do it until you get 0 tails. You're gonna have to keep going in your group until you get 0 tails. And I estimated how many times it would take on the table, but it might take more time, so you might have to keep your table going off to the side. It also might be done at like trial 5 or 4, you don't even know, because it's an experiment. For one. What? For one. If you are the luckiest human being in the world, you'll get all heads of the same at the first try. Okay, and then you could just be done. Okay, when you're done with that, just make sure that you have 100 pennies at the end and put them back into the container. Any questions about how that works? So the goal is how many trials dumping out does it take to get 0 heads is what we're trying to find. 0 tails, all heads.
Do we only have 7 tries?
No, you can keep going, but you might need to make the table go a little further into the margin. Do you know what I mean?
Yeah.
I just sort of estimated something, but. Do not, excellent question. Do not write anything in the theoretical data, table. We're gonna do that together later. Okay, remember, you need to make sure that you actually have 100 first, because I don't trust other classes. You can divvy up the task by putting them in piles of 10. This isn't even a damn penny. This is a Canadian coin. If you want to throw it away and get a penny, that's fine with me.
$7. Yeah. You can get 8. You can get 8 Arizona.
Okay.
Oh, no.
Yeah, that Canadian coin actually.
This is not the time to be multitasking on your Chromebook. That is not what we're doing right now. Counting 100 pennies, put them in piles of 10. We can each do stuff.
Sometimes other times.
Oh.
That's good.
Okay, now you tell. Like new.
I probably put it one. Oh, no, don't forget to write the number down. That would be really bad.
Say whatever.
Oh. Really only like $10. I was on.
Yeah.
So we did it years ago. They don't. It's pretty spot on though. Wait, we can just count the children. No, absolutely not. I'm looking at My guess was 2 off. I wonder what number that is. I was 6 off. But I don't live theoretically in third.
So try.
Again. What? Yes. Theoretically, there should Yeah. Because there should be those events. But that doesn't sound how likely.
I'm gonna say good.
Like,
There's five. Yeah. Bottom. Took 11. Oh, Alex,
guys, it gets easier as you go, there's less to work with. Combine Arizona with this. Oh, it went all the way to 11. Okay, I'll grab them. Took 11 tries. It was a long time. Okay. Oh, no. That's annoying. It's a curve until you get to the bottom. No, I must have begged my mom that we can do something. And just go by and go like. I'm gonna beg you to get some, because I have to like. Get to the airport. This top. My mom can go to concert, it's like 2 different times. Someone is in a country. What if it's a curve and then we get to the bottom of the ground? Let's stop it. What's your? No, just put the things back in there. Thing. I can put a phone on and then I can put it out. Oh. My mom bought us tickets to Bottle Rock and out that way. Don't be jealous of the bottle. It's pretty good. You guys going to Bottle Rock? Not stop it. Let's make it one last number. No, that's all blended. Okay, well, it's Hey guys, I need you to be finishing up. I need you to go over here in the pile. Quickly, you want to go put it? Wait.
Hurry up, guys. Yeah.
You should like donate some of the money. I know, lots of stuff for it, but. I currently have like over 400. Did you do anything? I'm talking about not printing anymore.
I know, and I'm very sad about it.
You were talking about this at dinner last night. Technology's taking over everything.
Miss Helen, what do you think of my socks? Do we approve of the trans ice cream socks? That's where we're at.
I really wish you'd worn those yesterday and checked
I
for my
also
child.
wore my Cape Town shirt today. I know. It wasn't even intentional, and then I was like, oh, oops.
Yeah.
Yeah, for my birthday, my mom got me a bunch of pretzels. That's great. But now I have trans ice cream.
Okay,
We're starting class again in like 1 minute.
No, it's from how you Oh my god, if you took videos. Yeah, I need your number. I need your number. Yes, I will do it. I have your number. I have your number.
I
Yeah, I will definitely send you. Oh, okay.
Probably you might need to count.
I'm not counting anything. Next year's kids are counting.
Oh, 707.
Okay, why is there a penny? Oh, it's the Canadian. Okay. Excuse me, hi. We have to go again. Okay, so you guys should all have values filled in here. And now we're gonna talk about what should happen theoretically. So theoretically, if we're in a perfect situation, meaning like a computer, and we flip 50 coins or 100 coins, 50 of them on the first try should come out to be heads. If you're doing something perfect. Can you please do that faster and just, oh my gosh. Okay, and then if you did it again, theoretically, yeah, there should be 25. And in trial 3, theoretically, and this is where it's going to get a little weird, but you have to think you're doing a mathematical model, it would be 12.5. Now, exactly, but you have to remember, it's like a line of best fit, so it's not perfect. You don't. Okay, this is going to get even weirder. On the 4th trial, theoretically, you should have 6.25 heads. Theoretically. And on trial 5, you should get 3.125. And on trial 6, you should get 1.5625 heads. And on trial 7, 0.78125 heads. Okay, and that's not even the craziest part. Theoretically, you would never get 0. Because all I'm doing is dividing this number by 2. Theoretically, you would never get 0. What is that called in the, what's the line called that it would approach? No, asymptote. So you guys should be able to see on your graph that you kind of have an asymptote of the x-axis. Your curve should be approaching the x-axis, except for that you hit it, because you're not theoretical. You have actual real pennies. Okay. Did you draw the line? Just estimate the curve for your theoretical graph. I mean, for your experimental graph, don't worry about the theoretical graph. Okay, so next, what we're going to do is find the equation. So this is y equals ab to the x And what did we start with? 100 pennies. And theoretically, what should our multiplier be? Yes, but I'm going to write 1/2. But you can write 0.5 if you like to the x. And this represents a 50% decrease in pennies. Okay, so shift this aside and get your notebook. Can you imagine sitting there for the rest of your life and trying to get all heads and you just couldn't because theoretically you shouldn't be able to. Okay, so we're done with 54 and 55. That was the penny stuff. And now we're going to relate this back to your favorite thing, which is exponents. I know how much you love them. Well, sort of being sarcastic. I like them. We haven't done any since you left, really, so. Okay, now, on all of the problems that we did earlier in the week, did you guys notice how I started the table at 0? So I would go 0 was the start, and then I do 1, 2, 3, 4 in the table. Okay, the purpose of number 57 is to just make sure that we understand what happens when you go backwards in the table. I didn't start the table at negative anything. I started at 0. Now we're all smart. We know that in this problem, 0 is going to be 100 because that's the start in our equation. But I want to show it using the exponents. So y equals 100 times 1/2 to the 0. So I want to have a conversation about 0 and negative exponents again, which was not one of your favorite things in the first semester. So it's always good to go over it again. Does anybody remember what the 0 power is? 1. Okay, so this is 100 times 1, which is 100, which matches our table. We plugged 0 into the equation, reminding you 1/2 to the 0 is 1. So 100 times 1 is 100. Okay, that's not really exciting. You also know from the work we just did with the pennies that on trial 1, you should get 50. Trial 2, you should get 25. And trial 3, even though it's hard to bend your brain around, you should get 12.5. Exactly. Now I'm just back to math and not pennies. So decimals are okay. Now what I want to talk about is what to do when you go backwards on the table. Yes, okay, but I want to talk about that in terms of the exponent. So y equals 100 times 1/2 to the -1. So I'm plugging in -1. I want you guys to all see common sense wise, this is going to be 200. How do I get 200 out of this? Yes, excellent. The -1 makes it flip. If you heard no other words from this problem, that's all I wanted. The -1 makes it flip. And this is 200. Okay, now let's see what happens with -2. Now you know it should be 400, right? Just common sense. You can tell it's 400. So the negative makes it flip. But the squared is still there. Let me say that again. The negative makes it flip, but the squared is still there. So this is 100 times 4, which is 400. For D, we're going to say negative exponents flip fractions. Are you okay? Are you all right? Okay, so now we're going to apply what we just learned from this problem into number 58. This is the end, by the way. Using what? I don't know. The book just did, and I thought they were cool, so I went with it. I had fun writing them. Yeah, I like to say little I and little I and little I and okay. Little I. Little I says 1/5 to the -1. Negative exponents flip fractions. So this is 5/1, but the 1 is still there. I'm just doing that. I know you can tell it's 5, but I'm doing the most over here. 5/1. 5/1 is still there. I'm just doing that. I know you can tell it's 5, but I'm doing the most over here. So flip a fraction, 5 to the 1 is 5. Okay, little I. Negative exponents flip fractions. 8 over 5, and then the 1 is still there. 8 over 5. No, we're just practicing what happens when there is a negative exponent. Because I don't want you to ever not be prepared. Okay, so negative exponents flip fractions. 3 over 1. The 2 stays. Makes it 9. Okay. 3 over 2. The 3 stays. Okay, now this is very important. We've been doing this in Math 3. You can tell Aubrey. We have to square each or cube each thing separately. So 3 times 3 times 3 is 27. And 2 times 2 times 2 is 8. So 3 times 3 times 3, 2 times 2 times 2. Now I've gone all crazy and I've thrown letters in there. Okay, so negative exponents flip fractions. B over a squared to the 1 is just b over a squared. Hold on. Okay, now you have options right here in this one. This one, you can actually cancel out the x's right now, or you can cube them and then cancel. I feel like we should cube them and then cancel just in case you have one that comes up that doesn't cancel. So this would be y to the 6, x to the 3rd over x to the 3rd. Notice I cubed everybody. Everybody gets a cubed. It's like Oprah's book club. You guys know that. Okay, now x cubes cancel. Y to the 6. Okay, can you guys find your stamp sheet when you're done? Yeah. Do you already know what the homework is?
Yeah.
Find your stamp sheet. Mine seems to have escaped. Here it is. Okay, let's look see what the homework is. So we did 54 to 58, skip 56. Homework is 59 to 65. In the last 7 minutes here, I'm going to bring you your tests back.